Guys, and welcome back. Today we are going to discuss the solution of theory of computation final paper solution. Okay, so let us begin. Let us discuss question 1. Question 1 part A states, give the notation of representation for the following components of formal languages. Alphabet. The alphabet is represented by the sigma symbol. String. A string is represented by the symbol W. Empty string. An empty string is represented by the symbol epsilon. Length of the string is used to represent modulo of W. Prefixes and suffixes are used to represent, prefixes are used to be represented by plus, A and B, where A and B are notations, and suffixes are represented by A, B and plus, where A and B are again notations. Language is represented by L of G, which is used to represent a given language in context-free or context-sensitive grammar. For operators on a language, different operators can be performed on a language, such as union, which is represented by A union B, intersection, which is represented by A intersection B, difference, that is A minus B, concatenation, that is A dot B, and clean closure, that is represented by star. Okay, let us look at part B of question 1, which is define FA and acceptance of a string by FA. First of all, FA stands for finite automata, and a finite automata is a 5-tuple. It is given by 5 set of symbols, which is Q, which is a finite set of states, sigma, that is used to represent the set of finite alphabets, delta, which is the state transition function, Q0, which is the initial state, and F, which is the final state. A finite automata has 2 states, the accept state as well as the reject state. That is, a string can either be accepted or rejected. When the input string is processed successfully, then the automata has reached its final steps and this string will be accepted. A finite automata is of 2 types, a deterministic finite automata, that is DFA, and a non-deterministic finite automata, that is NDFA. Let us look at the part 3 of the question. Give 4 differences between DFA and NDFA. First of all, the full form of DFA is deterministic finite automata, while the full form of NFA is non-deterministic finite automata. A deterministic finite automata is not competent in handling an empty string transition, while an NFA is competent to handle an empty string transition. DFA needs more string, while NFA needs less space. In DFA, empty string transitions are not noticed, while in NFA, empty string transitions are noticed. Let us look at the next part. State true or false. We are given a set of sentences whether we have to detect whether it is true or false. First is L is a language accepted by NFA-M, then L is also accepted by a DFA. If there is a language that is accepted by an NFA, then for the NFA an equivalent DFA can also be constructed, and if the language is accepted by the NFA, it can also be accepted by the equivalent DFA. So it is true. For every NFA, that is non-deterministic finite automata, there exists an equivalent DFA that simulates the behavior of NFA. It is true that for every non-deterministic finite automata, we can construct an equivalent DFA, which simulates the same behavior that the NFA has. So the sentence B is true. In NFA, that is a non-deterministic finite automata to DFA, which is a deterministic finite automata conversion. For n states in NFA, there exists almost 2 into n states in DFA. It is not true because there may be exponential number of states and it cannot be defined by a simple formula. Thank you so much for watching. Please like and subscribe.